So this is 2.4C College Algebra. I'm on page 220. Just finished that last example, example 3. There are some times, which is probably most of the time in your life, where it would be really nice if we could get some information from the general form of the quadratic formula that we have right there, instead of having to do completing the square and all this other stuff in order to find the h and the k and the vertex and the maximum and minimum points, etc., etc. So if there was a way that we could real quickly and easily find out where the vertex is of this hyperbola, that would be, or this parabola, that would be great. So this is a cool little trick in order to find out not only quick and easy where the x-axis or where the x-intercepts are, but also to find out where the vertex is. Okay, and remember the vertex is going to be, if we have a graph, where the graph, this point right here, the lowest point here, or if it's flipped over, it'd be the maximum point. We're trying to find that point right there, and that would be great to be able to find that. So what we're going to do here, and I'm going to really need you to focus on this to see what happens. When we use the quadratic formula in an equation, so we have this equation that's written here, we use the quadratic formula to find the x value, or to find out where the graph crosses the x-axis, the roots of the equation, or the zeros of the equation. So by using the quadratic formula, we're finding out, like I had in my last graph here. See if I can find it. Oh, I don't have it. Okay, so we had this graph and we did this. Alright, so when we solve for this, we're finding this point and this point where it crosses the x-axis. Okay, if you notice, the vertex right here is halfway between here and here. So if I were to do averages like you did a long time ago, and I were to take this length, or I'm sorry, this whole length here, and divide it by 2, I would get that point right there. So that's what I'm going to do. I'm going to take, when I do a parabola like this, I'm going to get one value that's negative b, because you get for an answer negative b plus or minus this. So that gives you two answers where this is going to cross. It gives you negative b plus this, and it's going to give you negative b minus this. So those are my 2 points. Those are going to, when I put numbers in here, I'm going to get one number for an answer here. When I put numbers here, I'm going to get one number for an answer there. Well, if I add those two up and divide by 2, I'm going to get this point right there, that halfway point between both of those answers. And that ends up being the x-coordinate of the vertex. So one of the things that you would love to see is if I could take this whole equation here and make it a lot easier to remember. And that's what we're going to do. If you were to solve this, or simplify this, you would find out that this entire thing, and I'm going to get rid of some stuff up here on the top so I've got room to write. If you were to take that whole bottom that I had there and reduce it or simplify it, you would get, when everything cancels and the dust settles, negative b over 2a. Okay, so that is the x value of the vertex. So if I've got my graph here, and I've got my parabola here, and I know where this point is and this point is, I can find this value, or my axis of symmetry, another good thing to remember, by adding this, which is the negative b plus the square root of b squared minus 4a all over 2a, that distance, and this point right here, add those two together, divide by 2, and you will get this x-coordinate right there. So for example, if I had f of x equals negative x squared plus 14x minus, let's put 47 there. Okay, to find the vertex, all I have to do is take negative b over 2a, and that'll give me the x value of the vertex. So I do that, and I get a negative, my b is 14, over 2 times negative 1, which is negative 14 over negative 2, which is 7. So that point where my axis of symmetry is and my vertex is, I came over 7. Okay? Now I didn't find out how far up or down I go once I get to 7. I didn't find the y value, so I haven't found both places, the x and y part of the coordinate, but I did find the x value. Now, if I want to find the y value, that would be real nice to be able to do, because right now I found out that my f of x, or my x value is 7. Now I just need to find my f of x value, my output when I put 7 in. What's my y value when I put 7 in this equation? Well, that's what I'm going to do. I'm going to say that f of 7, so I'm going to put 7 in, is negative 7 squared. And, oops, I'm sorry, not negative 7 squared. Let's put negative 7 squared. Okay, so we're just squaring the 7. Plus 14 times 7 minus 47. And when I do that, when you do the math, you end up getting 2. So right here is the actual math that got me the 2. So when x is 7, y is 2. So actually my blue line that I have up here is incorrect, because my vertex is actually, I'll do it with blue again, my vertex is actually here, 7, 2. Okay, so what's the problem with that? Well, the main problem is that this is a negative sign, so it should be upside down. So again, I'm going to kind of redraw it. So this ends up being your official graph going down with your maximum value of 2. So that would be the answer to B. And the range then would be how far my y value goes up, which in this case it goes up to 2 and it goes down to infinity. So my range would be 2, negative infinity. And it would include 2. So there you go. Not too bad. So your x value again is going to be negative b over 2a, and your y value is going to be the function of that. You're going to plug that answer in to the original equation, and that'll give you your y value. So then you end up with that for your x and y, which is going to be your vertex. So the example in the book, example 5, using some applications, says that there's a stone mason. He's got enough stones to enclose a rectangle patio with 60 feet of stone wall. So his stone wall that he has enough stone for 60 feet. So he's got this house here, and we're going to go out the right hand side. He has enough stone to do, if I were to add up all 3 of these sides, this side plus this side plus this side, we're going to get 60 feet linear, the perimeter of 3 sides, because we don't need stone here because the house gives me that one. So we're just looking at 3 sides. What they're interested in is what is the maximum area that the mason, or the guy that's putting the stone wall up, what's the maximum square footage that he can enclose? So, you know, we had talked about this earlier. If we've got this 60 feet and we make it 2 feet by 30 feet, so 2 by 30, we get a 60 square foot, or I'm sorry, we have to add them up and get 60. So if we do, this is 40, and this is 10, and this is 10, so that gives me 60 linear feet. Multiply those, I get 400 square feet. But what if, instead of making one 10 by 40, I end up using 15 by 30. Well, that gives me 450 square feet. So even though I'm still using 60 feet here to here to here, I get 450, whereas this 10 plus 40 plus 10 is only giving me 400. So this one would be bigger. So the question is, what is the largest? I don't want to just sit there and try a bunch of different numbers, every number out there, to figure this out. I want to find out if there's a formula that I can make this work, and that's what we're doing in this one example 5. So here's my house, and the red is the stone wall. So I know it's going to be 60 feet. I know this side plus this side plus this side is going to be 60. So my width I'm going to call W, and this width I'm going to call W, and the length here is going to be 60 feet minus this W here and this W here. So we'll just say 60 minus 2 W's. So that'll end up being the length of that stone wall. Okay, so my area using W is going to be the width times 60 minus 2W, right? That'll give me the width, or the area. So when I do the math, I get this equals 60W minus 2W squared. Okay? So there we go as far as that's concerned. Now what we're interested in is the vertex of this graph of this equation here. Because it's got a squared sign there, it's going to be a parabola. And the thing we know about a parabola is it's going to have a maximum or a minimum point. And in this case, it's going to have a maximum point. There's going to be a time where this place right here is at the highest value, where we have our width and our length, and when we look at them, it's going to give me this high point right here. That's what we're looking for. And actually, we're looking for the vertex, where the highest point is, and that's going to give us the most square feet, because after we go past there, the square footage goes down, and before there, the square footage is smaller. So we're looking for that point right there. So we're looking for the vertex. And remember, the vertex is negative b over 2a, f of negative b over 2a. So that is the vertex there. So if this is width and this is the length, you know, this distance right here, that's an L, we can put in the numbers that we have and see if we can find W. So W equals negative b over 2a. Okay, which means we have 60 over 2 times negative 2. Okay, because what we're going to do, we're going to switch these around so that they're in the right order. Negative 2W squared plus 60W, because this number here represents the A, and this number here represents the B. Notice there's no C. So that gives me as an answer 15. So the width is 15 at the most area. So this came over 15. That's my x value. Now I need to know how far I had to come up. Well, all I'm going to do is take this 15 and I'm going to plug that in to 60 minus 2w and end up getting 30 for that part of it. So we went up 30 feet. So 15 wide, 30 long, 15 wide gives me my 60, and that gives me my answer. 15 by 30 is going to be the place where I have the most square foot.